Welcome back. This is the third lesson recording for IM1, January 12, 2021. So, from the Desmos activity, it asked you, can you predict what 421st term would be? Okay, that's going to be way too tedious to repeatedly add 2 to get to the 421st term. Is there a shortcut? Is there an easier way? Well, mathematicians are renowned, known to be very lazy, or we like to think of ourselves as being efficient. We're looking for patterns so that we can figure out a quicker way to solve the problem. So let's see if we can come up with an equation. That's what's going to be helpful for us. To do that, first thing is if you have the sequence 5, 7, 9, 11, and a sub n refers to some term number with n being a variable. Okay, so n is a variable and some value. A sub n refers to the nth term and what is the value of the nth term. So the first thing you decide is this is arithmetic sequence because you are adding 2 to the previous term to get to the next term, right? With the common difference is 2. This common difference is 2. So then you introduce the zeroth term. What is a zeroth term? Well, we know that this is the original sequence and we know that 5 is the first term and 7 is the second term, or a sub 2. So the zeroth term is going to be the term before the first term, or whatever the number, if there was one before 5. And to get to that, so we know that to get to the next number you are adding to go backwards, instead of adding 2, you're subtracting 2 from the first term. 5 minus 2 is going to be 3. So we figured out what zero term is. And now let's consider the fourth term. Okay, how did we get the fourth term from the zeroth term? Well, from the zeroth term, the reason we got the zeroth term is from zeroth term, the common difference of 2 is being added 1, 2, 3, 4 times. Or we can say that to get a sub 4, 2 is added 4 times to a sub 0, or a sub 4 is 2 plus 2 plus 2 plus 4, 2, which is common difference being added 4 times. And then to that, we're going to add what we started off with, which is 3, okay, the zeroth term. So we can rewrite this as 2 times 4 because 2 being added 4 times is same as 2 times 4. And notice that 4 and 4, they are the same number here. Okay, and that's not a coincidence. If I was to go for the fifth term, a sub 5, I am going to be adding 2 5 times, or 2 times 5. I'm multiplying 2 by 5, and then to that I am going to add the zeroth term. So I can generalize it for a sub n, the nth term. To get the nth term, a sub n, 2 is being added n times. So remember n and n here. So 2 is being added n times, or we can say 2 is being multiplied by n plus 3. 3 is the zeroth term. Okay, so this is the more generic equation that's going to help us figure out any number term, whether it's a really huge number or small number. Okay, so then let's use that. So we figured out a sub n is 2n plus 3, and we want to figure out the 421st term. That means we can substitute n to be 421 and then use the equation. So instead of n, I am going to substitute 421. So 2 times 421 plus 3, that's going to be 842. And then to that, you're adding 3 to it, so that's going to be 845. So I know that 421st term is 845. Great, so now you're taking notes. This is the generic form of arithmetic sequence equation. A sub n, that means the nth term value is always going to be D represents the common difference and A sub 0 represents the zeroth term value. Okay, and this again is something that we've introduced. It's not on the sequence in itself. Okay, something that we've introduced that tells us the previous number. If we had to predict what the previous number was from the sequence, then it will be the zeroth term. So to calculate any term in the sequence, if it is a position, if its position is n, then I can use this equation to calculate its term value a. All right, so this is my um, equation. What is the equation for sequence of 12, 17, 22, 27, dot, dot, dot? Okay, if I have my sequence, if this is my sequence, what do you think would be the equation? Well, I know that 12, 17, 17 to 22, 22 to 27, common difference is you get the second term, subtract the first term, that's 17 minus 12, which is 5. And then we also want to find the zeroth term. If we are adding 5 to get the next term, then what should I be doing to get the previous term? Instead of adding 5, you're going to subtract 5. So that's going to be 12 minus 5. That's going to be 7. So 7 is my zeroth term. So I figured out what D is. I figured out what A sub 0 is. Now I can put it together and substitute D for 5 and then A sub 0 for 7. And so this is the equation that tells me the nth term for this sequence 12, 17, 22, and 27, and so on. So with that, you are going to be working on card number 16 to 24. So please pause the video and try to work on them on your own. Okay, this is card number 16. Now for the arithmetic sequence of 5, 11, 17, and 23, find the common difference, find A sub 0, and then use the information to write the equation for the term. So first thing, we need to find the common difference. How do we figure out what the common difference is? We get the second term, which is 11, and take away its previous term, which is 5. And that's going to be 6. So this tells me 5 to get from 5 to 11, you added 6, you added another 6, and then you added another 6. Okay, so we figured out what the common difference is. Now we need to figure out A sub 0 or the zeroth term. Okay, to figure out what zeroth term is, remember we added 6 to get to the next term. To go backwards, instead of adding 6, we're going to subtract 6 from the first term. So that's going to be 5. Take away 6, that's going to be negative 1. So we figured out the common difference is 6 and the zeroth term is negative 1. So substituting that into A sub n is equal to D times n plus A sub 0. That's our generic arithmetic sequence formula that you're going to have to memorize. That's going to be A sub n is equal to, we know that D is 6, so that's going to be 6n. And the A sub 0 is negative 1, so it's going to be minus 1. So that's my equation. And the next card just walks you through the steps. Okay, now card number 18 is use the equation that we just derived. A sub n is equal to 6n minus 1 to find the 201st term for the sequence. Okay, in this case, what we are interested in is when n is equal to 201, right? This is the equation we found, and we're trying to find when n is equal to 201. So A sub 201 or 201st term is 6 times, instead of n, I am going to put 201 minus 1. And I know that 6 times 201 is 1,206 minus 1. So that's going to be 1,205. So A sub 201 A sub 201 is 1205. And card number 19 just walks you through the step that I just described. Okay, card number 20. Now we have a new sequence with a new equation. If your sequence is represented by this equation, a sub n is equal to negative 5n plus 10. Okay, remember that the equation, the general equation is a sub n is equal to d, the common difference, multiplied by n, that's the term number or the position, or plus a sub 0. Okay, so or the 0th term. So in this case, what is, notice that n and n, they are the variable. Okay, sort of like the x that we used to deal with. Now n is the variable, and to that, what is the number that is being multiplied? It's negative 5. That means d is negative 5. So d is negative 5. If common difference is negative 5, is the sequence going to be increasing or decreasing? It's decreasing because you're adding a negative number, so the numbers are going down, so it's going to be decreasing. Okay, and the next card asks you to go ahead and calculate the first three terms of a of n is equal to negative 5 and plus 10. So let's start with a sub 1. A sub 1, that means n is equal to 1. That means we're talking about the first term. So where we have the equation a of n is equal to negative 5n plus 10, instead of negative 5 is still the same, but instead of n, we're going to put 1 plus 10. That's going to be negative 5 times 1 is negative 5 plus 10. That's going to be 5. So I know that a of 1 is 5, so I can put 5 here. What about a sub 2? That means n is equal to 2. So that's going to be negative 5 from the original equation times, instead of n, I'm going to use 2 plus 10. That's the original equation. Negative 5 times 2 is negative 10 plus 10. That is going to be 0. So I know that a sub 2, or the second term, is going to be 0. And finally, the third term is negative 5 times 3 plus 10. That's negative 5 times negative 15 plus 10. That's negative 5. So I know that the third term is negative 5. And again, you can tell that the sequence is decreasing because it's going from 5 to 0 to negative 5. And then card number 22 just summarizes what we just found. And then card number 23. For the sequence represented by this graph, try to write the equation that can be used to calculate the nth term in the sequence. Your equation should start with a sub n is equal to, and should depend on the variable n. Okay, so to figure this out, okay, we need to first figure out what is the common difference. What is the common difference? That means it's asking you how is the a sub the term value increasing. The term value here is, this is 22. So that's going to be 1 comma 22, and this is 2 comma 34 and 3 comma 46. How do I know this? When I click on the button on that, it gives you the coordinate. So if I click on this, it gives you that coordinate. So how, when the n increased by 1, how much did the value increase by? It increased by 12. Okay, so that means to figure out, so I know that common difference is 12. And now we need to figure out what a sub 0 is, or the 0th term. When n is equal to 0, okay, so it's increasing by 12. That means we want to figure out what when n is equal to 0, we subtract 12 from 22. So 22 minus 12 is 10. So I know that this is going to be the when n is equal to 0, and it looks like it's going to form a straight line like that. So a sub 0 is 10. So that means the common difference is 12